Okay, so let me start with a quick overview of the sitemap to DF function, and then we'll go through a lot of details. We're going to be looking at foreignpolicy.com today. Their XML sitemap. It's a fairly large one, a bit more than 100,000 URLs. So it should be interesting. So the main parameters of this function is, as you can see, first a sitemap URL. You give it the URL of the sitemap. This typically runs concurrently with 8 workers at a time, and you can change this. You'll make it much slower if maybe you're getting blocked or something, or you want to make it faster. You can do so. Recursive equals true is typically for sitemap index files. So when you say recursive equals true, it means get all the sub sitemaps, concatenate them into one data frame, and give me one master data frame of everything. And sometimes you don't want this; you just want the sitemap index. In this case, you set this to false. Now, the sitemap URL can take any of these 4 options. It could be a normal something.com/sitemap.xml. It could be a sitemap index. It could be a robots.txt file. It will discover the sitemaps there and concatenate them into one. It can also be a zipped sitemap. So all of these are equivalent, the same. They get handled, and you get your data frame. So let's do a simple example with Google's sitemap. So this is their sitemap.xml regular file. We don't know if it's what it is. So I set recursive equals false. And this is what I got. So it's a sitemap index, okay? So the location, the URLs here are not URLs, they are sitemaps. So this is Gmail, forms, slides, sheets, and so on, okay? So let me just quickly go through the columns over here. This is location, the URL. This is which sitemap it belongs to, okay? So later on, when you have like 20 sitemaps or 100 sitemaps here, you know each one where it came from, and so you can filter them and analyze them and so on. Sitemap last modified. This is a response header. If available, you'll get it. It's, you have to check the accuracy of this. This is like 20th of June this year. You have to, just make sure. The size in megabytes of the sitemap. This is a good check because you don't want to go beyond 50 megabytes, the limit. And download date. This is a reference for you. This was done today. So once you re-download the same sitemap, you want to compare. Okay, this was 3 months ago or last year or something. So this is a good reference for you. Okay. So next, what I did is ran the same function, but recursive equals true, which is the default, which is this. And we get a data frame with 46,000 URLs. Here they are. Location here, change frequency, priority. Google says they're not important anymore, but they have them. And this is the sitemap that it belongs to, and the other stuff over here. So these are for the docs sitemap. This is just a sample of 5. And these URLs are for the drive sitemap, another sample of 5. And in some cases, you see errors over here. So most of these are not available, but in some cases they are. So we can easily count those. So they have 49 sitemaps that are, and this is the error code, not well formed, invalid token, line 16, column 37, syntax error, and a 404. What's really interesting is that on Google's sitemap, there's a 404, and out of all the Google websites, the one that has a 404 is this one, believe it or not. So if you're feeling not so good on one day, you can come here and it would cheer you up. Anyways, so let's do the big one for today, which is the foreign policy sitemap. So I just went to the robots.txt file, downloaded it, and just in case, I converted it to CSV and have it here for reference as a CSV file, so I can refer to it later. Okay, so sitemap raw is the one as is, and then sitemap was the one deduplicated. Okay, So as you can see here, the original one has 714,000 URLs, and after deduplication, it went down to 115,000. Okay, so much, so many duplicates over here, about 83%, and it's like almost 600,000 URLs duplicated in the same sitemap. They don't have errors. There's no column here for errors, so they don't have any errors in the URLs of their sitemap, and they have last mod, which is very interesting, especially for publishing websites. Okay, so now we can do a few quality checks. So if we take the sitemap column on its own, for every URL, it tells me which sitemap it belongs to, and we can count those. And what this tells me is how many URLs you have per sitemap. Okay, and we get the series and we describe this. So those counts are described with these descriptive statistics, and we just convert it to a frame and make it look nicer. So the important thing here is we have 238 sitemaps. The average number of URLs is 3,000. The most important thing is that the maximum is not above 50,000, which is the limit allowed. Okay, we can do the same thing with the sitemap size in megabytes, and the maximum is 0.5 megabyte, which is tiny compared to the maximum allowed, which is 50 megabytes. Okay. So next thing is what we can do as usual when we have a bunch of URLs is URL to data frame, split everything into its components. And the good news here is that we have the publishing date as part of the URL. Okay, you see the year / month / day. In many cases, in some cases we don't. So we can split these and then extract with this regular expression and convert it to a date time. And now we can have a publishing date column over here, which we can and will use. Okay, so as you see, we have directory 1, 2, 3, 4, 5, and last directory. We have a few query parameters: post type, p, attachment ID. We don't have any fragments. So it's good to get an overview of these URLs. Okay, so the first thing is how many of them have a publishing date, like this one over here. Okay, and it seems we have 72%, which is 84,000 almost URLs that do have data about the publishing. And the ones that don't are about 31,000 URLs. Now, there's something very interesting here. Also strange, this is just a random list of 20 of those URLs. I'm going to just show you quickly what they are. Most of them are just empty pages like this. Okay, if you look at the source code, nothing, absolutely nothing. Size 0, status code 200 yet, but this one has content. So it's interesting. So we're going to focus on the stuff that has a publishing date because it's the majority of the URLs, and these are not returning much. So once we take the publishing date, we can take any attributes of the publishing date. And let me just quickly show you. So this is the publishing date. If the date is not available, it's not a time. So this is not available. You can say .dt.gear .month day, and if you have second weekday name, was it? No. Yeah, so you get the weekdays. Monday, I think, is 0, 1, 2, 3, 4, 5, 6. There was one that gives you day names that give you Sunday or Monday. Anyways, no problem. So the first thing I did was take the years and count them, and get this simple chart. So I can see when they've been publishing and when they've gone down. This is very interesting to know that on 2009, they jumped from like 3,000 to 8,000. Doesn't look natural. Something must have happened there. And then they were a bit consistent, and then it went down, and now they're like at almost 2,000, 3,000 the last year. So this is a very big question to ask or probe if you can. But it's very interesting insight to uncover very quickly, just by looking at the dates in the URLs. Okay. Now, because we have last mod in the sitemap, we can compare these two and take the last mod as a date time and compare them over here and see a big difference. Okay. So yes, they have a spike which doesn't, you know, go away starting in 2009, but they have a new spike in 2015. Now this might be an actual modification of many URLs. I don't know, but it's something to ask and check. Okay. And we can go systematically through every component of the URLs and see them. We start with the scheme. It seems everything is HTTPS. Everything's fine. You'd look at the network location, the domain. Do they have other domains or subdomains? It seems everything is foreignpolicy.com. No problems there. We can do the same with directory 1, and we'll see that they're mostly show top, let's say 40. Okay, so there's slideshow, there's newsletter, but these are like just 800 and 200. So the majority are years, okay? And 2, it's pretty much mostly months, 98%, and so on, okay? So to summarize the utilization of these URL components, so when I look here, I see directory 1, 2, 3, some of them are empty. I'd like a summary per column over here, which you can get with this simple code. So what I care about most, since we know that we just have one domain, is that directory 1, 2, 3, and 4 are 100% full. So every URL has 4 directories. Some have 5, but it's you know, so small, like that, so few that they've been rounded to 0. And those queries are almost practically 0, so we can ignore them. So my website here is 4 directories, and we've seen here that directory 1 is you know, so the first 3 are year, month, date, and the 4th one tells me what the article is about. Okay, so this is what the overwhelming majority of URLs look like: year, month, date, and the article title. Dash, 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 split between them. So we can take the last directory, okay, and count the words in them and see what topics they've been covering the most. So United sometimes States and sometimes United Nations or United other stuff. That's why they're not exactly the same, but it's mostly US. War, China, Trump, Russia, Iran, how, Obama, state, etc. And you can see how many articles they've published about every one of these topics, because these are like the topic is in the URL. We can do the same here with bigrams. So we can specify phrase length as 2. And I also added some stop words here, like of the, in the, etc. And you know, US, foreign policy, United States, UN, situation report. It gives you a better, not necessarily better, but a different view that augments this one. Now, this is a very, very high-level overview of the site, which has been publishing for decades. So yes, obviously it's, you know, US and war and China. These are key topics. What we can do, especially that because we have the dates in the URLs, we can make this interactive and go through the years or months that we want. Okay. So this is the same report as you can see above, but it has this slider where I can use it to restrict the dates. So between 2008, let's say, and 2015, as you can see, these are changing. So we have Obama here, obviously between the years when he was president, and you can narrow it down and see what they've been focusing on in every given year. Okay, so you can go here and do this 2016, 2019, and see what they've been covering. You can go to, let's say, only 1 year, for example, from 2021 to 2021, and see how things have been covered. Now, this can be done with even another dimension, which is the keywords. Okay, so we see, for example, Trump here covered extensively. Obviously, he's the president. So what we can do here is enter the word Trump. And what this does is it's going to filter all the URLs that contain that word over here, this regular expression, and counts the words in those URLs only. So when they've covered Trump the most, the biggest topic was Iran, then China, and then Russia, and then Biden. Okay? And keep in mind that this is foreign policy. This is not domestic policy. So the fact that they're not covering local stuff is normal. But I think it's very interesting that with Trump, there's much more focus on Iran than there is China and Russia. So we can also say China or Chinese and ask what they've been covering together with China. So it seems US, Russia, Trump, Xi, war, and so on. So you can, go with tech, that's very interesting. From 2010 to 2022, tech, when it comes to foreign policy, technology is about China, or that's the most associated topic, big war report, and so on. Okay, you can, and this is, you can go whatever, Google, also China, and you can change the dates and see what they've been focusing on for every topic in every period that you're interested in. This takes a regular expression, so you can change it any way you want. Another thing that we can do is use the racing chart function, which gives us this interactive chart. So these are the top 20 words in the URLs per year, okay? And you can play it and see how things have developed across time, and you get totals here and the years, and you can see them going up and down, and you can, manually change it and see how things have evolved. Russia and Ukraine are top 2 topics over here. They practically did not exist 2 years ago, which is expected, and so on. You can dig deeper into these things. Now that we have the URLs, we can use the crawl headers function and go through all the sitemap, all the URLs in the sitemap, and run. This is crawling with the head method only. It doesn't make a get request, so it just gets the response headers and the status codes. Okay, and I've enabled throttling here. If you were here last time, you would know that this makes it, vary the speed so it doesn't hit the servers very hard. So the majority is pretty much all status codes were 200, nothing to see here. We've had some redirects. We have 117 redirects, and this is the full chain of redirects. Most of them are 1 redirects. So this was requested, but it was redirected to this one. And these are the status codes that we have over here. Download latency you can get, but this is a bit misleading because you don't have the full page. But it's, you can look at it and see which ones are very high. So the majority, these are the ones that are less than 2 seconds. This is where they are, and these are the ones more than 2 seconds. So we can filter the ones that are like 10 seconds or 20 seconds or 100 seconds and see what's going on there. Okay. And this took me about 6.5 hours to crawl because of the auto throttling. It's 100,000 URLs. But the good news is I got all of them 200 status codes, and I think it was good so far. Yeah, these are mainly the things I wanted to share. I'd like to know what you guys think. If you have any questions, feedback.
This is one of this and the spider crawl thing were like the two first things. I think this is actually how I found AdverTools originally when I was looking for
Oh, really?
um, really good sitemap parser in Python. The challenge that I had, and I can't remember if I had a chance to test AdverTools with this, but the challenge I had was I had a huge nested thing of sitemaps, and it was something like 8 or 9 million URLs, if I can remember correctly,
Oh, wow.
across all the different sitemaps. Yeah, and I should go back and test it. So obviously my first question is, what's the largest like network of sitemaps that you've processed with this? I'd love to know
The
about like
the
performance and
largest
stuff.
was New York Times. I
Okay.
think it was like 4 GB of URLs
Okay.
because they have
Yeah.
every URL since 1830 something. So they've digitized everything, and it's a fairly large website. So it took like one full day. I have it, I think, on Kaggle. I have a bunch of sitemaps. It's there. Um, yeah.
Yeah. Okay.
Do you remember which one yours was? I'd love to check it out.
I do. I can send it to you directly. It's a client, so I don't want to
Okay, okay.
mention it on the
Yeah,
recording
yeah,
right
yeah.
now. But
Sure, sure.
I'll send it to you on messaging later. Yeah.
Right.
Yeah. But yeah. Okay. So you've scaled it to very large sitemap networks.
I mean, the typical sitemap doesn't go above like 100,000 or 200,000
Um,
mostly, but it's always good to see
yeah.
how
Yeah.
this can be. So if you have a very large one and you want to split it, as I showed at the beginning, you can set recursive equals false, okay? And then,
Okay.
one by one, download, save to a CSV just in case, because if it's going to take a lot of time,
Yeah.
you don't want to get disconnected or something wrong happening.
Totally.
So this might be a good strategy to do so.
Okay. That makes sense.
Cool.
Makes sense. Yeah. There's a feature that you showed that I hadn't thought about that was really cool as well. I'm trying to remember what it was.
Sitemaps,
Do you
errors.
have this notebook somewhere? Like,
This is very similar to one on Kaggle. I'll share this one as well. The dates,
okay. Okay.
parsing the dates, or
Uh, that I did like this. This was really cool. I think it was before that though. Anyway, it's not a big deal. I don't want to take too
okay,
much time on that, but
cool. Yeah, it's fun when you have publishing and you go through what they've been doing. I think that the sitemap is the one that gives you the most bang for your buck as a ratio.
yeah,
It's
yeah,
nowhere near crawling. Crawling is where you get the full information, but this one is very quick. You get 200,000 URLs if you have dates and you have information there, then it's amazing what you can uncover, and you're not annoying them with it. Just small text file, download it
right.
and
Yeah,
analyze it. And it's fairly straightforward. URLs and then
yeah.
URL to DF, and you count the values and parse them, and you get a good insights about that. I mean, I'll share the whole thing, like the data and the code, so if anyone wants to look.
Do you happen to know if the number of workers is that gonna use like all the CPU cores? or is it all
It's
just going to be in
it,
one?
no, it doesn't use multiple cores, but it uses multiple threads. So
Okay,
you might heat up your computer.
right.
Um,
Yeah.
but it's just make sure you don't get blocked if you have too many, unless you inform the website that you're going to be running this very, very fast. So one trick over here is
Yeah.
um, so this is the sitemaps module. You have the headers dictionary. Okay. Sometimes you get blocked. So what you can do is headers and say user agent, you can change that to something else. Sometimes, and I'm thinking of adding
That's good
this
to
to,
know.
to the
Okay.
function itself, or you
Yeah.
can add other headers, like if changed before this date, don't download it, or download only the sitemaps that haven't been changed. You can put any request headers over here and make it. Some people find this useful. I think it should be part of the function over here, where you can change the headers the way you want. It might help.
What's your favorite proxy API for doing? Does this work with the proxies as well, or is that just within the
No,
crawl?
no, that's just within the crawl. Um, Unfortunately, yeah.
Okay.
So how would this? Let me think about this, but
Okay.
I'll check. Are you getting a lot of issues with this?
Not with this in particular, but
Okay.
we just, because of the volume we're dealing with, we usually have to go through some proxy to get a lot of this stuff. What I've done in the past when I have to download all of the XML, like the sitemap files, is I'll just use um, something simple like curl or something to download the files and then just process everything locally.
Okay.
Um,
Okay.
and if
Yeah,
I have to for a proxy to get those files, then I'll just do it that way.
I see. Yeah. Yeah, we can look into this one and see what can be done. Cool. So it's clear.
Yeah, it's great.
Wonderful.
Yeah, I really liked just how you were quickly able to see like what was trended per year. I think from like a competitor analysis perspective, you could go in, grab someone's sitemap, and just say, hey, like let's see what this group has been focused on or whatnot over the last year, even 6 months, since you could break down monthly. And kind of, I mean, relating that back to search, you could just see, all right, if they're focused on this content, if we wanted to break into this, this is some of the challenges we'd be going up against, or maybe, they find a different segment, for a client site to go after if they feel that the competitor has a certain area on lockdown. So
Absolutely.
I think, I think that's really good.
Great.
Yeah.
Yeah, it's quite limited, but it's gives you a lot of insight for very little information that it contains, and then
Yeah.
it can inform your crawling and other stuff later on.
It's a really interesting. I mean, this is. I was thinking about this a little bit last night when it comes to structured data
Hmm.
as well, because it seems like with SGE and stuff going forward, that having more detailed data feeds uh, available, like Google and maybe OpenAI will want to look more at the data that comes from a property versus the content over time. And it
Okay.
occurred to me that unless I'm just completely misunderstanding how everything is set up on these, schemas and so forth, that there's nothing really like a sitemap directory of all of the different data elements you can find in structured data. Like you have to go to each individual page to get that. But I could like maybe have like a sitemap for the data, the structured data, like linking all the different elements together. So you don't actually have to go to the URL and visit it, and you can just get the data out of it, and then that could be used by these different language models, to help people navigate products and so
So
forth.
there would be a live analysis of these websites and their structure and their relationships in the search.
Yeah.
Most likely, yeah. I mean, and it could be done through a plugin or directly, if in the case of Google.
Yeah.
I mean, if you want, like, what's the percentage of topics on this website that cover bicycles versus shoes, whatever, and it might be able to do that for you.
Right.
That's maybe that's a product to think about as a plugin to
Yeah.
sell those LLMs, search engines.
Could be.
Great.